So today I will be drawing the VSEPR diagram, the box diagram, and the contour diagram for NO2. I will also be including some extra images and information about NO2. So first things first, in order to find the VSEPR diagram and draw it, we have to figure out how the Lewis structure looks. So I went ahead and counted the valence electrons. There's going to be 5 for nitrogen as illustrated right here, and 2 times 6 for oxygen, because there are 6 valence electrons in oxygen and there are 2 oxygen molecules, equals 12 plus 5 equals 17 electrons. So since there are 17 electrons, we know not every single molecule is going to be able to reach an octet. So I went ahead and added a double bond right here. We'll put DB for double bond, and then I went ahead and distributed the remaining electrons to find that there is a free radical above nitrogen right there. Put FR for free radical. So ultimately that is how the Lewis structure will end up looking. So now that we've found the Lewis structure and how it looks, we can go ahead and determine how the VSEPR diagram looks. So first things first, we should look at the electron pair repulsion strength to figure out the bond type and the bond angle. So we know that a lone pair bonding with a bonding pair is going to be stronger than a bonding pair and a bonding pair. We have a lone electron bonding with nitrogen. It's actually going to push down the oxygen bonds, ultimately creating a bent shape. And since the shape is bent, we know that the angle is going to be less than 120 degrees, as indicated right there. So since we know that, we know there are going to be 2 sigma bonds and 1 pi bond. 2 sigma bonds representing the 2 bonding pairs of oxygen and nitrogen. And then above I also indicated another VSEPR diagram, and I went ahead and labeled everything, N obviously for nitrogen and the O's for oxygen. I also labeled the free radical up at the top here. And so from these 2 figures we can determine the molecular geometry to be bent and the electron geometry to be a trigonal planar, which ultimately allows us to determine the hybridization to be sp2. So that means there are going to be 3 orbitals that are going to be hybridized. So here are some more images. At the top we have the atomic orbital. So I went ahead and labeled the pi bond right here. And then you can see the sigma bonds as well. Right here is one, and here would be the other one. And then the second image is just the atomic orbitals overlap. It's once again signifying the bonds. So then here's the pi bond, and then the sigma bonds right over there. So basically I already drew the box diagram. I included everything, the ground state, the excited state, and the hybridized state for nitrogen and oxygen, but we can see that both nitrogen and oxygen do not get excited, so they do not have an excited state. So they both just go straight to hybridization, and the hybridization was sp2. So we can see that in the green, I went ahead and bonded these 2 simply because that corresponds to the nitrogen bonding with the oxygen, and then that would be a sigma bond as I labeled it right here. And then we would have a pi bond over here, because these are the 2 orbitals in the nitrogen and the oxygen that right here that we did not hybridize. So they will bond and form a pi bond. And then in the blue we have another sigma bond. It's basically just a simple nitrogen an oxygen bond. And then lastly, in the yellow is what is going to give us our free radical. And it is ultimately what provides the nitrogen with a lone electron. And I also included the VSEPR diagram right here, just for reference and to see, once again, the free radical, and to have it as a reference when drawing the box diagram. You can see the bonding between the nitrogen and the oxygen, and as illustrated in the box diagram. So this is the completed box diagram. Yeah, so next we will go on to draw the contour diagram. But first, I wanted to draw attention to the molecule built with the model kit, because it's basically a real life representation of NO2. So you can see here we have the double bond. It's the same picture, it's just different angles. And then these are going to represent the lone pairs on the oxygens, and there's one back there. And then on top of the nitrogen, we're going to see the free radical illustrated by a little white circle right there. And then lastly, right here, we just have your basic oxygen and nitrogen bond. It's a single bond. So yeah, it's basically a visual real-life representation of the model, and it comes in handy when drawing the contour diagram, which is what we are about to do. So this is the completed contour diagram. We can go ahead and see the pi bond right here and right here. And then we can see the three sigma bonds right here. I'm sorry, 2 sigma bonds right here and right there. And that just symbolizes the nitrogen bonding with the oxygen. Right here we see the nitrogen bonding with the oxygen, and right here we see the nitrogen bonding with the oxygen. And then here is where our free radical is. So that is where our lone electron ends up. And then I also labeled the angle right here. It's going to be less than 120 degrees because, as we established previously, right here, the molecular geometry is going to be bent. And then over here we see our lone pairs on the oxygen. And yeah, that's going to be the completed contour diagram.